The report comparison of the seismic loading of points on the surface of the Earth during a massive explosion in a mine is presented by Anastasiia Zdeshchyts and Valerii Zdeshchyts. As a result of industrial activity, the Valerii region has developed serious environmental problems. The mining of ore in Valerii led to the formation of numerous underground cavities, which over time come to the surface of the Earth with the formation of a sinkhole. Problem: along with the processes of movement of underground cavities to the Earth's surface, there is a constant threat of destruction or damage to residential buildings, violation of the integrity of the mountain massif due to mass explosions and quarries and mines. These explosions also affect the rates at which voids emerge. This leads not only to unpredictable exits of funnels and the development of landslides, but also to the threat of rock strikes in mines. The purpose of the research is to compare during an explosion in a mine the seismic load of points on the surface of the Earth with their orthogonal location in directions. The task of the research is to obtain a set of data related to the amplitude and frequency characteristics of seismic waves that have passed through a half-kilometer layer of rock, and to determine the intensity of seismic oscillations at observation points. Setting up the experiment. 3-component sensor of seismic oscillations were installed near the foundations of residential buildings and industrial buildings in the area of the industrial site of the mine, which were located in almost opposite directions. Parameters of a mass explosion. The mass explosion at a depth of 387,527 meters was carried out using the technologies of blasting with well charges. The well charges were detonated in short bursts. The number of wells is about 220. The total mass was 44 tons. So, on average, the charge of the well was about 0.2 tons. As you know, the main environmental criterion of the seismic hazard of an explosion is the density of the seismic wave, which can cause damage to the structures of buildings. The magnitude of the vector velocity determines the density of the energy flow. Therefore, as a characteristic of energy, it is directly related to the conditions of damage to structures. Damage to the protected object occurs if sufficient energy penetrates into it from the seismic wave. Without this energy, damage cannot occur, even if the force characteristics exceed those required for this in the case of statics. Therefore, the measurement of seismic parameters was carried out in this experiment by recording the vector velocity of soil oscillations. Results: the duration of ground vibration was close to 6 seconds. It is noteworthy that the shape of the signals is almost identical, but the values of the maximum speed differ. At a shorter distance from the explosion, the amplitude is almost 1.5 times smaller. To explain this phenomenon, it is necessary to obviously recognize that the existing fractured area between the blasting wells and the DP observation point acts as a screen. It is known that when seismic waves collide with a cavity in rock, a phenomenon called refraction occurs. Part of the energy of the waves is reflected back, and part is refracted and continues to move. This leads to a change in the speed and direction of wave propagation, which is reflected on seismic oscillograms and can be used to monitor the geological structure. The oscillogram obtained from the third seismic sensor of the DEF also confirms this regularity. The value of the maximum vector speed registered by the DEF seismometer was 0.61 cm per second, which corresponds to 3 points and almost more than 2.1 times the maximum speed registered by the DP seismometer and 1.4 times more that registered by the DO seismometer. So we can see the clear influence of the rock structure on the amplitude of oscillations of soil particles near the foundation of residential buildings, the dependence of the direction of seismic wave propagation. The influence of these factors is also observed in the works of other researchers. Although the distance to the industrial site was the shortest, due to the passage of seismic blast waves through the collapse zone and the loss of explosion energy, the lowest speed of ground vibrations was recorded at this registration point. To explain the obtained non-trivial results, a frequency examination of the obtained oscillograms was carried out. The frequency spectrum was studied. The results of spectrogram processing are given in the table 2. According to the results of frequency studies, it can be concluded that there is some correlation in the region for more than 10 Hz between the frequency properties of seismic signals from DP and DF sensors installed on different sides of the rock massive destruction zone. Such a correlation between the signals of the DP and DO sensors is not observed, which indicates a different structure of the massive that the seismic waves from the same source passed through. And this experimental fact provides a method of monitoring the structural changes of the massive. Conclusions. The method of simultaneous measurement of the vector speed of oscillations of soil particles on the daytime surface from one underground source of seismic waves is considered. A comparison of seismic load of points on the surface of the Earth during an explosion in a mine with their orthogonal location along directions in the conditions of the destruction of the rock body in a separate area was performed. The intensity of seismic explosion vibrations near the foundations of residential buildings and industrial buildings in the area of the industrial side of the mine, which were located in orthogonal directions, was determined. It has been proven that the intensity of seismic waves that have passed through a half-kilometer layer of rock is not determined by the known laws of their attenuation in a homogeneous environment, but entirely depends on the structure and properties of the rock. Studies of the frequency characteristics of seismic signals have also confirmed this fact. Thank you for your attention.